The navigation bar on the user interface can be found at the left-hand side of the software. This is where we keep the tabs for inspection, camera, communication, parameters, program creation, zone setup, and system locks. The inspection page monitors the shadow board and keeps track of what tools are available on the board as well as their counts. This information is updated as the user interacts with the board. We'll show more details regarding this page later on in the demo. The camera tab keeps the configurations for setting up the cameras and shows camera health. This will include parameters such as exposure time, gain, gamma, white balance, and more. The communication page next will monitor whether a stable connection is established and maintained across the front and back end of the system. The parameters page will allow users to review and tune any model parameters or thresholds available in this program. This will be program specific. The program creation page is what's being shown right now on screen. This page allows users to build new logics into the program or alter existing logics and will take parameters from configurations. We'll come back to that later. And then finally, we have the tabs for setting up different zones as tools get relocated on the shadow board over time, as well as one more for displaying system locks. The program creation space is made user-friendly by allowing the operators to develop new programs or make changes to existing programs simply by dragging and dropping boxes around. These boxes are pre-built by Ascension with all the necessary logics for setting up a program, so the end user doesn't need to worry about writing a code in a specific program language. Once the block structure is established, our software will create the underlying code to update the system and run the new program. The current structure, for example, is set up with a camera block, an AI model block, and several other logic blocks that determine how tools are tracked throughout the process. The variables stored in each of these blocks can be conveniently changed to satisfy new project requirements. For instance, the original block here is set up to track powers, but it can be easily changed for tracking other tools, such as the heat gun. From here, we could access the zone setup page, which allows us to create and modify different zones for tools on the shadow board as they relocate. There are different shapes and sizes available to set up regions of interest, and we use this technology to track what belongs where and flag illegal operations. Once the setup is saved, the zone information will be updated automatically into the program. We'll now show the inspection page to demonstrate how the system works. Here, we use multiple cameras to monitor different sections of the shadow board. Every camera gets a slice of it. The names of the tools and their quantities are shown and tracked in the table below. During the first demo here for range A, we show that a 916 wrench is borrowed and one too many wrench head is returned to the shadow board. As we perform these operations, the vision system sees that the wrench is being removed from the board and changes its status to borrowed and flags the wrench head for attention because the extra wrench head here does not belong. Next, for range B, we show that multiple tools are being picked up from the shadow board at once, with their tags in the table below all changed from OK to borrow. In range C, the tool DT0273 is borrowed and then returned to the board, alongside with an extra tool being placed in the wrong slot. For range D, we show that multiple sockets are borrowed from the board. And finally, for range E and F, we show that similar operations can be done for tools that are located more towards the bottom of the shadow board. Also, the overall stats of the program can be seen by clicking on the Get Total Tool Counts button. Thank you for watching.